Thank you. I hope everyone can see my screen. Sorry that took a minute to get going, but I am basically going to tackle what is quite a big and broad subject, and I'm going to try and highlight a few things I've found interesting, a few things I've sort of worked with recently, maybe sort of share some of my experience and give some pointers to where relevant resources and how you could take things further. So I've got a bit of an agenda, which I'll try and put up next. So I've tried to make it quite an accessible talk, so not really assuming any knowledge beforehand, but we're going to start with a bit of an introduction just to set the context of sort of why I'm talking about this, what it is I'm talking about, and then we'll get into the topic of packaging. We'll run through a quick example. I'll talk about zip apps, which is something I find fascinating. I really am keen to take that area further, and then system packages, which is a topic that comes up a few times, and I think it's better to be forewarned about and maybe to have seen some of the examples rather than to jump straight into. So the later sections sort of build on some of the earlier sections. So while we start off kind of assuming no knowledge, but by the end you might it might help to have listened to some of the earlier parts of the talk. So I've got a few slides, not too many, so hopefully you'll bear with me. I'm going to talk for about another 35 minutes. So I kind of put a limit on it because I could talk about packaging for a very long time. We have to narrow down the kind of subject of packaging, and what it really leads on to is how you get the Python code out to users. It is really broad. So I've deliberately kind of cherry-picked a few different areas. So I'm not going to talk about packaging vendors. For a little while, I did work for a startup in this space. I worked for a kind of package management software as a service company. I'm not going to talk about packaging for kind of particular proprietary runtime platforms. So at the moment, I work a lot with Google Cloud and their cloud functions. The way that packaging is handled there is a little bit different to how the kind of open source, more standard kind of Python ecosystem handles it. So I'll leave that for another talk. The packaging, to my mind, can be quite a controversial subject, right? There is definitely more than one way to approach packaging in Python. I'm not going to tell you what the right approach is. I'm going to tell you about some of the approaches that have worked for me. There are a range of tools, and recently with some of the standardization, some of the PEPs that have come through in the last couple of years, it's not just setup tools and things that build on top of setup tools. There are genuinely different kind of end-to-end tools that you can use to package up your Python code. I have some preferences. I'll try and keep what I explain objective, but it should give you a bit of an overview. Anything that I don't talk about, I'm happy to pick up in the Q&A. The Q&A will be time limited though, so let's see what we get onto. So when I kind of finished this presentation, I realized that I'm coming at this from a certain angle, and I thought I would try and spell out a bit of what maybe biases I have, or why I'm going to highlight certain things when actually you might be interested in a different set of things. So in general, I much prefer to use open source tools where I can. So you'll maybe see me talk about, I don't know, GitLab rather than GitHub, or that might feed through into some of the material. If I can, I'll go for the simpler solution. So that might involve kind of fewer moving parts, or just a less sophisticated answer. I'm very in my work. I kind of work as a back-end Python developer, but I also do, or certainly have done, kind of roles where I'm a cloud engineer, or I'm applying DevOps principles. So there'll be quite some of the talk will touch on automation and those DevOps principles, right? And then I've also got a bit of a a reluctance to try the most exciting and newest thing. So I'm kind of aiming this at not the bleeding edge of the most recent packaging developments, but at some things that are sort of new, and if you weren't keeping an eye out for, you might not have seen. So things that are maybe 5 years old or a couple of years old, but not absolutely brand new. Okay, so let's actually get on to some of the material talking about packaging. There is a lot out there, right? So some of the best material I'm aware of is called the Python Packaging User Guide. That is up on python.org, and if I had to jump into it cold, I would absolutely point anyone who's interested in this topic at that overview. So some of the material appears a little bit unpolished, or it might be a work in progress. There's a GitHub repository is quite easy to find where you can contribute to it, but I think there's some absolutely brilliant material on there. I'm not going to rehash it here, but I'm going to kind of draw the minimum together that we need to have some of these other conversations. So in there you'll find lots of material about maybe deploying to Microsoft Windows, or the differences between a library and an application. Here I've sort of simplified just to fit into the talk, the time I've got for this talk. So I'm going to kick off by pulling in a few terms. The best place to get a kind of authoritative definition for these is the glossary up on the packaging.python.org, but the terms are perhaps sometimes a little imprecise. So I'll just run through these quickly. Hopefully there's not too much debate around them. So a module is sort of the smallest unit of kind of shareable Python code. So a module typically maybe is one file with a .py extension. A package can mean a few different things. So that glossary is trying to be more precise. It's trying to use the phrase distribution package to mean maybe an artifact that has a number of different modules inside it. Another type of package you'll hear me talk about today is a system package. So a system package might be a DMG on Mac OS, or it might be for your Linux distribution, it might be a part of their system package installer, be it apt or yum or DNF or any of those. Another useful distinction to draw is that between a library and an application. If you're writing Python code, perhaps you're writing it for another developer to make use of. It's probably a library then. If you're perhaps targeting an end user, it's maybe more likely to be an application, but the way that you package libraries and applications, there are some differences. Okay, so what do I mean by a package? There's a range of different formats you've probably heard of, right? So wheel, I would say, is probably the most common Python package or Python artifact, and wheels definitely have some advantages. Generally, I was really interested at one of the recent conferences chatting to someone from Microsoft who was explaining that they don't really rely on wheels. They much prefer SDists, and then they build compile some of the compile some of the shared libraries and other artifacts you'll get inside a wheel from scratch. An SDist is a kind of standardized format that lays out your Python source code, so your .py files and the metadata in a particular structure of archive. So a couple of other things that we might mean when we're talking about a package is we might be talking about an installer, and I'm going to try. Windows is the operating system I've worked on least recently, but I'm going to try not to skip over that. And then something else which I will go into much more detail on is an executable. So the example we'll talk about later is a zip app, or it might be a .exe on Windows, or it might be there's a range of different executables you might package up. The last thing I was going to mention on this slide is about container images. Container images, to my mind, are just a different way of doing packaging, right? They have a very specific set of tools for working with them, and they generally package up more than just Python code. They typically package up nearly everything in an operating system. So the best known example of that is Docker, but there are others, Podman, Kubernetes, different ways to run containers. So when you see that phrase package, it isn't always clear, especially when you look with quite a narrow focus. When you're looking just at Python, a package might mean a set of modules, or a package might mean a distributable package, in which case it's probably a wheel or a zip file. So sometimes it's worth clarifying what that word is getting at. So one of the kind of fundamental things I want to cover in this introduction is that Python on its own is a lot less valuable than Python as it's integrated into an ecosystem. So a lot of Python's success, and Python is very successful at the moment, or very popular, comes from Python's ability to integrate into that wider software ecosystem. So just an example of that, Python's popular application for Python is data science or machine learning. A lot of those libraries that you're going to rely on aren't going to be written in Python. They're going to be written in perhaps a compiled language or something faster. So the Python packaging isn't just about Python source code. It's often about more than that. So wheels, which we just talked about, enable the distribution of compiled artifacts. So shared libraries or other things that might be built from a C or C++ or Rust or Fortran or one of these other languages. The reason you would want to give your end user a wheel rather than rely on them compiling it from source code themselves is that they might not have the software, all the build time dependencies that are needed to put together that wheel, or they might not have the experience, right? Often there can be a bit of setup involved in getting a project building successfully. I am going to talk a little bit today about sort of good practice or suggest some kind of modern approaches to packaging. But in my experience, certainly at the companies I've worked at recently, and these have been small companies, startups, if you like, packaging is a bit undervalued or maybe neglected. You often see it only getting attention when it breaks. So I was just thinking about this yesterday when we stood here with the slide, are we talking about packaging Python? Yesterday I was wrestling with a problem where it was a C library that was stopping my Python code running. I was trying to render some images, and because that library that was underlying the Python package, nothing would work, and I was a bit stuck. So the last thing I wanted to mention about packaging Python here is the idea of many Linux wheels. So many Linux wheels, if you haven't come across these before, and there are a few different flavors of them, are a way of targeting a lowest common denominator. So making sure that your Python and the other libraries and the other artifacts that have come out of your build process work across different flavors of Linux. Linux is quite fragmented perhaps, but there are different versions of C libraries or different versions of system libraries, and many Linux targets are very stable and very kind of old-fashioned, or like basically a lot of the early versions of many Linux were built on a Red Hat Enterprise Linux, which typically had a much older versions of the software, but that meant that it would run on the wheel that you compiled would run on both those older versions, but also more recent ones that were sort of backwards compatible. So Python packaging often ends up being about a lot more than just your Python source code. Hopefully we've covered what is a wheel, but a wheel is really an opportunity to distribute not just that Python source code, but some of these other artifacts that you get from building other languages. Okay, so starting to jump into some more kind of recent developments. Reproducible Builds is an initiative that's been around for a few years now, but I think the thing I want to say about it today is it's very accessible, right? If you have the source code for your project, it's not difficult using the modern tools to go to the packaged artifacts in a completely repeatable way. So on the screen there's the kind of definition of what is a reproducible build, but really that's about being able to control the environment where your software is built so much so that it's completely bit by bit reproducible. So if I build it on my laptop and I build it on the CI system, we get the end result down to the we get the same end result down to the closest one down to all the ones and zeros. Reproducible builds aren't, people don't universally get excited about reproducible builds. I'm enthusiastic, but that doesn't mean everyone is. So I thought it might help to explain a little bit about why are we talking about reproducible builds. So reproducible builds really came about from a security perspective. They are a great way to sort of prove that the software that you're running corresponds to the source code that maybe you've reviewed, or maybe that you trust because it's up on GitHub, that someone hasn't set some malicious features, shall we say, into your code base at the stage where they're building the artifact. So some of these types of attacks have actually been seen, not so much in the Python world, although there were some vulnerabilities or potential vulnerabilities shared reasonably recently. The example I'm thinking of comes from the JavaScript world, where there was an attack on Bitcoin wallets because not because the attacker had been able to access the source code repository, but because they'd been able to add in malicious code at the packaging stage. Another reason I'm a big fan of reproducible builds is sometimes build systems or packaging systems can be, shall I say, time consuming to debug or fault find or dig your way through. So in my experience so far as a Python developer, I've had I call it the opportunity to work on a lot of quite interesting systems. I can definitely point at a Jenkins build and deploy process that I was working on recently, where if we'd had reproducible builds, I wouldn't have lost days and days trying to reproduce or trying to debug why a particular package didn't include what we expected it to include. So that kind of plus about debugging is secondary to the security arguments, but I think it's a valid point as well. And then the last point I would make about why reproducible builds are interesting is that they're so easy, right? So some of these tools kind of give you them almost for free. So we'll hopefully come back to reproducible builds a little later in the talk. So why are we talking about Python packaging, and why are we interested in it? To be honest, I don't think it's only interesting when it's necessary, and it isn't always necessary. My answer to this question is a resounding no, not always. So packaging really helps when you've got a larger or more complex project. Doesn't help so much on, and I would argue it even kind of hinders when you're on something smaller. So this is an example I pulled out. We'll come back to this application a little later, but Virtualenv is, hopefully some of you are familiar with it, but it's been around a long time. It's been around nearly 15 years. And the original author, writing last year, said that for most of its life, it was a single file project. So if your Python application works as a single file, there's no need to split it across directories and add packaging tooling and make it more complicated. The nicest kind of pattern I've seen for maintaining a Python application in a single file is, and a lot of this I'm sure will be familiar to you, but is your imports at your top. Define your functions first, and then have an if name is main call the functions. The thing that I found interesting or useful about this that I hadn't seen until recently is that you can actually also include your tests inside that same source code file. So this example I kind of took from a podcast called Test and Code, which is very good, but I'm a big believer in tests being an important part of this packaging story. Some people have a preference that, or make arguments that tests don't belong as a part of an artifact or a package that's created. I've found the arguments to include them more compelling than not. But if whether it's a simple application in a single file and you can include your test there, or it's a more complicated package, you've got the option to include your tests alongside the source code. So we have decided we need to create a package, and it gives us some opportunities, right? It gives us an opportunity to lay out the code in a more structured way. I was just talking about tests, so maybe you're going to have a test folder and a source folder for the actual features that you're implementing. Maybe you're going to structure it so that some of your reusable functions are in separate modules, and it gives you a lot more scope for making an easier to navigate code base. The second argument or second kind of benefit of putting together a package is that it lets you document information you probably already know. Like if you're writing an application, you'll know what version of Python. I hope you'll know what version of Python you're working on, or maybe what version of libraries you have installed. But the packaging process lets you document that in a machine readable way. And then the last opportunity that packaging brings is it makes it quite easy to publish something and to know that an end user has the same code as you have. So the public example might be you're publishing something up to PyPy, where there are different ways to structure repositories private repositories inside a company. There are open source methods like GitLab, or the other vendors have solutions as well. Okay, so that was quite a lot of kind of context and background, and now I'm going to just go through what I hope is quite a simple example of creating a package. So if we've been talking about this 10 years ago, you wouldn't have had many options, but nowadays, one of the first things you do if you're going to package up some Python is choose what is the tool you're going to want to use. I had a look through that list of tools up on python.packaging.org, and there are more than I remember, right? It's quite an active space at the moment. So there's a surprising amount of complexity in the metadata and the kind of structure that Python packages have, and a good build tool will hide that from the developer. So there are, like I sort of said in the introduction, there's more than one good build tool. The sort of default one is setup tools. Setup tools will let you will do most of the steps we've talked about already. It won't handle publishing. So the kind of default publishing tool is called Twine. So setup tools and Twine is a very common option to take, but they are a little bit encumbered by having to support a long history of different versions. So Flit came along in 2015 and is another project. It's somewhat simple. It kind of targets a happy path and sticks to it, but it covers the publishing use case as well. Poetry is one I have used a little bit, but it is bigger in scope again. It will cover installing packages, managing virtual environments, as well as building packages. So the example I'm going to walk through, we're going to pick up Flit, and Flit has picked up this approach from the Perl community, believe it or not. So is to make the easy things easy, and the hard things possible is the kind of second half of that. But Flit is very much focused on the easy use case here. So you might have a pure Python package that relies on, I don't know, a C library for some cryptography, or a Rust library or some other library, but that's separate. Flit will be great for that use case. Flit makes it very easy to do reproducible builds. The biggest kind of disadvantage I've come across with Flit is that flit publish command works great on PyPy and the PyPy test server, but I didn't have much success getting it working with some of the options for private repositories. So you can end up using a kind of a mix and match. So you could use Flit for building and Twine for publishing, or you could, if you know that's your use case, you might choose to go down the setup tools or the poetry or the enscons or something else, go down another route. Flit, I'm just going to mention here because it kind of triggered a lot of this change that I've alluded to recently. So up until 2015, you really only had a choice of setup tools or some sort of wrapper on top of setup tools. Now you've got a lot more of a range. There's been a big effort to kind of formalize the kind of default implementation that is setup tools into some PEPs to allow kind of competing implementations to come up. So that's just a bit of kind of historical context. One of the nice things about Flit is that you just have to run Flit init, and it will give you a like a wizard. It will take you through creating a package. The next thing to mention about Flit init is it won't cover everything, so you might need to add a little bit more to your PyProject.toml. The couple of things I ran through an example. It's not quite ready to share, but the two things that I needed to add on were the dependencies, so what other Python libraries I was using to write my application, and the entry point or how I would run that application. So the syntax for that's reasonably straightforward and on screen. So everything else, the build command, install, publish, are very much straightforward. So I'm going to move on and try a demo. We're kind of moving past the kind of basics and onto some of the slightly more unusual corners of the packaging world. So this next demo is a demo of the Virtualenv application. I'm hoping most of you have come across Virtualenv before. It doesn't really matter if you haven't. It's very similar to the VM module, which is part of the standard library, and it's just an example application, right? The fact that it sets up isolated environments for you to do Python work in isn't really important to this talk. So if you are interested in Virtualenv and a bit more about it, there's two brilliant talks at EuroPython. So the last couple of years, I'd recommend those. The first one is labeled as beginner. I would say the speaker there says himself that it's quite dense, so they're worth a watch, and I've had to go back and watch them a second time in places. So let's see how well this recorded demo works. Basically, we're starting up a Fedora container, and we're going to download the Virtualenv zip app. So if you go to the install documentation for Virtualenv, you'll see zip app's one of the kind of supported methods. We've downloaded the zip app, and this step we're just copying it onto our path, and we're marking it as executable and telling it where our Python, we're going to use the system Python in this example, and we're just writing that into the front of the file. The zip app module is part of the standard library and has been since Python 3.5. So there you can see slightly odd output from Virtualenv version because user local bin Virtualenv is a file. It isn't actually a directory like it appears there. So installing Virtualenv has worked, and we're just kind of doing a demo that, yeah, it's set up perfectly. So you might have a sort of a wonder of what's going on here. We've just downloaded one file, put it on our file system, and made a minor change, and everything seems to be working. The background or the kind of full story about zip apps is best explained in this PEP. It's actually it's remarkable how little exposure I think this had. When I came across it, I was really quite interested, because I think this addresses some of the perceived frustrations with Python as compared to some of the modern languages. So I can see really two arguments for using a zip app, right? The first one is one of convenience. Some of those other modern languages, like I'm thinking of Go or Rust here, get a lot of attention because they enable producing a single binary or a single file executable, and that makes some of the steps that come after packaging, so distribution or installation, a whole lot simpler. I think that zip apps kind of address a almost a shortcoming in Python and really are a great solution. The second big plus for me is about reproducibility. I'm very keen to run the same, not just the same like rough version of Python in my test environment, or not the same rough version of my application in my test environment as I do in production, or as the end users do. I'm really keen that it's bit for bit identical. We talked a little bit about reproducible builds before, so the idea that you can package up a zip app and just copy that onto whatever host you're going to run it on is a big plus. Zip apps are surprisingly straightforward. So I learned a bit about the zip file format and how that's structured. The first thing to observe is really that that file that we downloaded is just a zip archive, right? There's nothing special about it. It's not an unusual file type in any respect. And then the last thing, the second thing to note is that it has a the call to Python-m zip app that we made did two things, right? It added the what's called a shebang line, which is basically just a line that points to whichever version of Python. Here I'm using the system Python, not always the best version of Python to use, but worked for this example. And it also marked the file as executable. So the reason that the shebang line at the start of the file doesn't interfere with the kind of compressed contents of the zip is that zip files encode their length and measure the length from the end of the archive. So it's almost like a count backwards from the end of the file to where the compressed data starts. So if you actually want to work with zip apps, you've got a few different options. If you just want to use the standard library module, you've got to do a bit of kind of manual work. You've got to download your dependencies. You've got to kind of structure them, put them into directories on the file system. Now that's possible, and the Virtualenv itself, right? If you go onto their GitHub page, you'll see a really clever implementation there where they managed to support a massive range of versions of Python, including still 2.7, by downloading various different versions of their dependencies and choosing which ones to execute at runtime. I certainly don't often have, I don't think I've ever had the opportunity to come up with a solution that advanced. So if you're using the standard library, you're probably going to have something more simple. There are a few different options in terms of kind of open source tools that make that easier for you. The first one, the first two I've looked at in a bit of detail. The third one's just sort of there for completeness. LinkedIn have a version called Shiv, and out of the Pants project, there's a tool called PEX, and both of these are quite clever in that they actually extend upon the zip app format. You remember right back at the start, we talked about, are we packaging up just Python, or are there other libraries or artifacts from compiled languages? Maybe there's a C library, something else that would be in our wheel if we were making a wheel. Well, the zip app as implemented in the standard library doesn't really support those other shared libraries inside the so Shiv and PEX are solutions that let you not just include pure Python modules, but pure Python packages, but include any Python package inside your zip app, right? The last thing to mention before I sort of leave this section behind on zip apps, when I first saw zip apps, I thought, oh, that's interesting. I've never seen that before. How and I was kind of excited and thought it was new. It actually isn't particularly new, and there are a few examples of more innovative, again, approaches to Python packaging. So the first one I'm going to mention is a project kicked off in 2018 that I've been following for a while. It's called Oxidizer. Oxidizer doesn't just include your application and its dependencies, so that, say, the Python libraries it uses. It includes all of Python, right? So it really is just a single file that you can copy onto a host, and you don't even need to rely on a version of Python being installed. It hasn't quite got to a version 1 release yet, so it's probably a little bit early for me to take it into an actual production environment. The other one I'm going to mention is Facebook have a project called Czar, and Czar uses, instead of using zips, which is quite dated as a technology and as compression goes, it uses squashfs file system images, and it mounts these. So mounting a file system image typically needs elevated privileges. It's not going to work quite as straightforwardly as putting a zip file in a directory, but Facebook, the authors claim that they get better compression, they get better compatibility, that this is a faster approach. Both of these I'm kind of keeping an eye on and might take forward. I can't say I have a lot of experience in using them at this stage. So the last thing I wanted to talk about is what I see as a solution to the same problem that, say, many Linux wheels solve. So if you're writing Python, one of the reasons you might be writing Python is because it works so well with the kind of software ecosystem, and it's so easy or so effective to call out to C code or numeric computing libraries or image transformations or machine learning, whatever kind of system software you might be thinking about, but you might have a need for. So one of the easiest ways in my experience to kind of integrate into a system is to work with one of the Linux distributions. I hoped to have an example ready, but I didn't quite manage it in time. Let me just see if I can find the example I was going to use. Here we go. Hopefully you can see that. So this is a reasonably simple application that I maintain in one of the Linux distributions, Alpine Linux. And it basically takes an email address as its input, an email message as its input, and outputs a list of URLs. But you're really not, this example uses setup tools, but you're really not having to write anything too complicated to get it packaged up. And these Linux distributions some of them have fantastic resources. The numbers of CPUs and the amount of RAM that their CI systems have is just phenomenal. So I maintain a few packages in Alpine Linux. I know other people maybe prefer Debian or Ubuntu or some of those, but I think system package managers have a lot of advantages, and it is definitely a valid solution to I need to deploy my Python application problem. I guess just for completeness, I'll mention one solution that I've wrestled with a few times in a professional context, and there are, so that was a sort of a native package I was showing you, one that's written in the same way that all of the other Linux distribution packages are written. There are shortcut tools, we'll call them. One, probably the most common one, is called effing package manager, that will take a Python package and convert it to an RPM or a deb, or will convert it to a package that works with the with a Linux system package manager. My experience with those has been a bit of a mixed bag. Sometimes they can be challenging. Right, that has been a whistle-top tour through a few topics in packaging. I hope there's some people still here, and I hope you've maybe a question or two.
Well, I have no doubt there will be a few questions. What do we have here? Nobody used the Q&A system, so feel free. Now is a good time. Don't be shy. Anyway, I have a bunch of my own anyway. So.
So someone,
yeah, it's coming. They're coming.
I'm just catching up on the comments, right? And there was a bit of a chat about Docker and hard disk drives running out of space. I think that's one of the great advantages of doing Python packages, right? And just packaging up the Python that you need. Docker containers have lots more in them than just your application code. So they have clever solutions like layers, but I do think that's a sometimes discounted advantage of packaging your Python software using the Python tools.
Right. So I don't know. Okay, I'll get you through the questions. So in order of appearance, we have Lorcan asking, congratulating you first, and that's perfect, and it should be done. Have you used Conda? You didn't really mention Conda, so
yeah. So
that's what can you tell us about that? You know, I see Olga, the data scientist, on the starting tracker, hunting you. Why don't you talk about Conda?
Why don't I talk about Conda? Conda, I think, solves a problem, and it's very much targeted at data scientists. And I think data scientists have slightly different requirements to maybe other types of Python software developers. Conda is a working solution, but it's maybe not the basically my experience with Conda is about 5 years out of date. I used to try and run a couple of CI. I think it was AppLayer I was using. I can't. There was a project or two I had where I tried to compile certain things using Conda, and it was a somewhat frustrating experience. So I think as far as I understand it, Conda, if you stay on the kind of happy path, and use kind of commonly use popular libraries, you'll be safe enough. I think when you try to go outside of that, you might have more problems. Is that fair to other people's experience?
It seems fair. It seems in the comments here that Conda has good Windows support. And Amba, which
may I have a related question? Just jump in. My own experience, if I have a choice between Conda and pip and same packages, like sometimes I just end up not knowing what's way to go where, like, because I don't really understand like why. I suppose pip has a different function, obviously, but in some cases you can have a choice between installing packages from one or another. Like, could you?
So my advice is to try and understand what you're installing.
Yeah.
So is it Python? Is it Fortran? I'd hoped to include some material about how you look at a dependency graph. So chances are you're writing some code that uses one library, but that library might use a second and a third library, and the third library might use a fourth, fifth, and sixth. And you can even get circular dependencies where the sixth one also uses the first one. Mm-hmm. So it can be really helpful to kind of print out that graph or have a look at that graph, just so you start to understand which packages might be causing problems. There are a couple of tools, I think, and I get their names wrong, they're not that well named. There's pipdeptree and deptree and Johnny Depp. And I haven't quite worked out which one's best, but I think I definitely recommend having a look at that dependency graph.
Yeah.
And a second bit of advice is when, and I only learned this the other week, but when you're using, when you're trying to install onto Mac OS, it makes a big difference what version of Python you're using. So we were trying to install libraries onto Python 3.7, which at this stage is a few years old. And it took days of wrestling with working through error messages and just pain. Whereas installing the same libraries against Python 3.9 was completely painless. It was a pip install. So I guess in a professional context, some of us are maybe tied to older versions of Python, and might not be the solution you want, but moving to a newer version of Python might solve some of your packaging problems too.
Yeah, like I'm a Linux, that's why I was delighted to see all these Linux examples on your site. So I don't know those problems with Mac.
I'm very new to Mac. It's an experience, shall we say?
Okay, yeah. Good luck.
We have Julian that asks, considering an SDIS, so source distribution, as far as it is my understanding, should you embed all files into it? Especially should you include the tests? So there is some sort of debate here. So either you try to slim down your version and you would include the test, or you would embed the test and say, yeah, user can make tests or run tests before I can software.
So
okay, if you don't mind to mute, please.
I'm actually midway through this debate at work at the moment. A slightly different context where we're kind of deploying cloud functions, and we're debating a change of how we lay out our tests, and it might result in us including test files in deployed artifacts. We include all sorts of junk in deployed artifacts at the moment, and so much that the tests won't make a difference at all. My kind of answer to that would come back to what are you trying to optimize for? I probably don't have megabytes and megabytes of tests for every application. They're probably quite small in the grand scheme of things. It might be that you're deploying onto an IoT device and every kilobit counts. But I think in the general case, I've taken the attitude that tests belong in the artifact, and I'd much rather be able to easily run the tests and know that everything's okay than have that couple of 100 kilobytes back.
Fair enough. Space is cheap nowadays. Let me tick that box. Jürgen is asking if you're targeting Windows, if you have any experience. It's an operating system that's quite popular with people who love Excel, and sometimes they need Python tooling as well. And what tool would you recommend to deploy some Python tooling on this?
My Windows experience is a little bit out of date. I think that one of the beauties of Python, like I was on a call for my job just yesterday, and helping some new people that have joined, and partway through we realized that there was 3 of us on the call, and we had Mac, Linux, and Windows all trying to run the same software. I think one of the best things about Python is that it has first-class support for all 3, and the Python kind of built-in tools, the batteries included, are pretty much guaranteed to work. So I think I would probably stick to pip and Python, and I try to get onto a reasonably recent version. I know that the Windows support improves. In terms of actual specific advice around, I nearly forget the name of the, is it the different versions of compilers and how you keep compiling software on Windows? I'm a little bit out of date. Was there a specific problem, or was it a general question?
No, I think it's kind of a general question anyway. We might come back to that specific if needed. We have an interesting question, because LD, which is quite an anonymous name in itself, is asking what packaging solution would you prefer to distribute Python code to anonymous people? I hope that's not some sort of threat with all
Right.
the anonymous things around, but we are the right guys, right? We're the good guys here.
So there's a real range of what you can use, right? So if it's open source code and you can put it on PyPy, there's no reason not to put it on PyPy. At the other end of the spectrum, there are vendors that will give you kind of secure ways of distributing code. So a couple I've used professionally are Artifactory and Cloudsmith. Cloudsmith's headquartered in Belfast, where I live. In the middle, there's also some of there's some kind of all-in-one solution. So GitHub and GitLab is one I'm more familiar with, have built-in package repositories into their kind of Git hosting, and they're quite good. It's quite a nice model to have a repository that's scoped to your specific project. So if it was anonymous people, I think you could use any one of those. I might be inclined to try GitLab just because, apart from it not working great with Flit, it's one I'm familiar with.
So we have still more to come, eh? If you were to target, but I think you kind of pre-answered that question already, so you feel free to make some vacuum here. But as you wish, what tool would be producing the smallest executable for Python program? Would PEX be good? If I may interpret the question quite a bit, as is my role here, it is maybe Julian here is targeting small embedded devices. I know we run Python now in full computers that would fit under the nail of my thumb. So maybe that's the story. There is some Internet of Things behind this.
I wish I'd done more with some of those kind of MicroPython and CircuitPython. I find that a fascinating kind of corner of the ecosystem, and love to hear about some people's experience of packaging there. I think a lot of the tools that we've just talked about are probably so I probably wouldn't use Docker in that example, right? Because Docker, you're going to have a lot of
Nope.
a lot of other things in the artifacts that you're trying to copy across. I think I probably would want to pick up a tool that does reproducible builds, just because reproducible builds give me a much better feeling of control over what the package is doing. In terms of so Oxidizer, which is one I talked about, it includes the whole version of Python in its output, so you would kind of discard that. I suspect you probably want to rely on the vendor who's maybe providing the hardware you're running on. They might supply a version of Python that's on there, in which case you're probably looking at copying something like a wheel across. So and you've lots of options in terms of what outputs your wheel. In the embedded space, you might be, so Flit, I talked about Flit as a great example for pure Python packages. In the embedded space, it's possible you might be kind of optimizing and dropping into a lower level language. So you might fall back to setup tools or look at one of the other options like Poetry if you need to compile C code, say, as a part of your packaging process. Yeah, so is setup tools an okay answer?
Yeah, I mean, it's about, pointing in a direction and then dropping some Latin words like Kevin does, So that's the feeling. So here comes the another elephant in that porcelain shop. It's funny. is there an answer to that? I'm not really sure. I've seen tons of debates about that. So say I have this great Python code and it has tons of intellectual property onto it, and I want to distribute that to my customers, but I don't want them to see my code base. How would you, distribute your Python software without disclosing the source code? How would you obfuscate that, all that shenanigan of, well, I'll let you answer that.
Just before I come back on that one, I saw some good stuff from Eric in the chat about many Linux wheels, and yeah, I think absolutely, if you're doing in that embedded space, you're going to be kind of building your own artifacts, and you're going to want to keeping that under control and looking at the size of things. So yeah, many Linux is great as a sort of beginner or where there's a lot of heterogeneity between the different systems. It sort of is a lowest common denominator, but I think when you're in the more kind of niche or advanced use case, you probably want to drop it. I think he's just right. How do you obfuscate your Python code? If my Python code's secret, I'm not going to send it to them. So that's not a great answer, right? If you're stuck in the situation where you, that's not a great answer, is it? How do I do this? How do I get there? I wouldn't start from here. Let's say you're in a situation where you have to share the Python code. You have to share your Python application. I think that not sharing the Python, the .py files, and just sharing the pyc files is one good option. I might look at something like Oxidizer that uses a slightly less well-known output format and maybe it's a bit harder to disassemble. But things like zip apps they're just zip files, and you can unzip them, and you can read the source code. And Python isn't that hard to disassemble either. So, I think
maybe we can keep that kind of conversation for after the formal Q&A, because I have my own experience on that. In the end, is you rewrite your code in another language is the solution. I would go.
Let's agree on that answer and postpone any further debate.
As soon as you're going Python, you can go with only the pyc. You can go through obfuscation, just like you can obfuscate and reduce, your JavaScript file. You can rename your variable to make them, stupidly ridiculous, difficult to read. But you can very easily reverse engineer all the the thing that has an economical value into your logic and algorithm. So if you want to protect yourself, you would go with physical dongles and encrypted hardware you would deliver at the customer site yourself, fully insured. And Python wouldn't be where you'd make your living. That would be for your early prototypes, and it would not leave your walls. That would be my answer.
So I think we're agreeing you could slow people down, but you couldn't stop them with Python.
Yeah. So